Hello everyone, my name is Mr. Sullivan. I'm one of the other Algebra 1 teachers if you don't have me. And today I'm going to talk about a different method to solve a quadratic equation other than the square root method. Mrs. Wood showed you the square root method the other day, which is a great method for solving a quadratic equation, but it doesn't always work. And so today we'll talk about a different method just in case the square root method doesn't work. So let's take a look at a quadratic. Remember, when we talk about a quadratic, we mean an algebraic expression that has that's of degree 2, meaning the largest exponent is a 2. So you can see this is a quadratic equation because it is of degree 2. Its largest exponent is the x squared. So if we try to use Mrs. Wood's method of taking the square root of both sides, remember she described you want to isolate the squared term. So in this case, the x squared is the squared term, so we'd move the 4x and the 1 over to the other side by subtracting. So we'd end up with x squared equals negative 4x minus 1, right? Subtract each of those values from both sides. Okay, and we'd end up with x squared equals negative 4x minus 1. So if we try to take the square root of both sides, it works wonderfully on the left. We end up with just the x because, again, those are inverse operations. The square root undoes the squared. But the problem is on the other side, on the right side, yes, we'd have to consider the plus and minus. Okay, and we could tee this off even, but we end up with the square root of negative 4x minus 1. And to be honest with you, I don't even really know what to do with that. When Mrs. Wood was showing you examples, you had things like the square root of 12 or the square root of 16. That we can handle. We can't handle this, and the reason why is because we have the square root of another variable. And so the square root method, you can see, doesn't really help us. So then what do we do? Well, we use something called the quadratic formula. And the nice thing about the quadratic formula is it will help you solve any quadratic equation as long as there are solutions. So it's a method that works every time. And so you can see the quadratic formula. It looks a little scary at first. You can see the quadratic formula down below in the box here. And so we'll go through this slowly, and you guys will get used to it. The quadratic formula is something that you'll use throughout your math career next year in geometry and algebra 2, pre-calculus and calculus, etc. So this is a big one. This is kind of like you learned the Pythagorean theorem, a squared plus b squared equals c squared. The quadratic formula is a biggie. So eventually you'll commit this to memory, so start trying to think about it. But what is it and what does it mean? Well, first of all, if we take a quadratic equation that's in standard form, and what I mean when I say in standard form is that it's set up like this, okay? I'll give you an example. If we had negative 3x squared plus 6x minus 2 equals 0, the expression on the left is in standard form, meaning it goes from the squared term to just the x term and then a constant at the end. We have it in that order. If I wrote it this way, this would not be in standard form because you can notice that the terms are out of order. So before we use the quadratic formula, we always have to make sure that our expression is in standard form and also that it's set equal to 0. Okay, we'll talk more about this as we move on, but you got to make sure that it's in standard form and set equal to 0. Now, when it's in standard form, it has, you can see 3 different numbers typically, not in all cases, but typically 3 different numbers that appear within the expression. Okay, there's the coefficient of the x squared term, in this case negative 3. Well, that's our a value. There's the coefficient of the x term, in this case a positive 6, that would be our b value. And then there's just a constant, just a number by itself with no variable, in this case negative 2, and that becomes c. Okay, so those are the values that we're going to use for a, b, and c. Once we identify a, b, and c, we're going to plug them into the formula to solve for x, and so we'll know that x will equal, and we'll plug into this big, again, kind of scary looking formula. It's not too bad, I promise. The a will go in twice. Okay, it appears twice in the formula, there and there. The b will go in twice, here and here. Okay, and c, poor c, only goes in once. Okay, goes there in the formula. The way we say the formula, just so you get used to saying it, is x equals the opposite of b plus or minus b squared minus 4ac, and the whole thing, everything in that numerator, is divided by 2a. Okay, so x equals the opposite of b plus or minus the square root of b squared minus 4ac is the quadratic formula. Just to introduce you real quick into some vocabulary, we're going to be referring to something called the radicand. The radicand, if you haven't heard this term before, is the number that's underneath the radical, okay, underneath the square root. We'll refer to that quite a bit when we're simplifying or solving using the quadratic formula, so make sure you're familiar with that. We talked a little bit about standard form. Again, we cannot solve using the quadratic formula unless our equation is in standard form, ax squared plus bx plus c. Now, don't worry, it doesn't always have to be a plus and a plus. There could be, the signs of a, b, and c could be different, but it does need to be in that order. And then finally, when we talk about the opposite of b, okay, the opposite of b means the opposite of whatever value b has. So if b is equal to 2, then when we say the opposite of b, when we plug that into the formula, we're going to want to consider -2. If b was equal to -7, when we plug into the formula, because it's the opposite of b, we would be using +7. Okay, so just a little vocabulary for you to get used to. So in terms of the steps, what we want to do is make sure that we have standard form. We'll practice more with arranging it in standard form, but we want to make sure our equation is in standard form and also that it's set equal to 0. Okay, we want to state the values of a, b, and c. It's always good to write those down so we know which values we're going to plug into the formula. We're going to substitute those values into the formula, and we're going to simplify it completely. Okay, and that means simplifying the radical, which you guys should be used to, and coming up with, in most cases, 2 solutions. And then once we come up with our solutions, we're going to go ahead and check those. Okay, let's give it a try. Okay, so here's our first example. Now, what I'm going to do is I always like to have the quadratic formula in front of me. So again, x equals the opposite of b plus or minus the square root of b squared minus 4ac, and that whole thing is over 2a. Okay, so there's my quadratic formula. Now I look at my equation and I notice that it's set up and ready to go, meaning it's in standard form, x squared minus 4x minus 12, and it's set equal to 0. So this is in good shape, ready to plug in. So what I'm going to do is I'm going to identify my a, b, and c values. What does a equal, what does b equal, and what does c equal? So I take those right out of the equation. Now, notice that there's not a coefficient of x squared. We don't really see an a value now. Be careful here. You heard in middle school the term the ghostly 1. Well, we've got to make sure we put that 1 in there. Okay, so it's really 1x squared. Be careful, sometimes students will call that 0x squared. It's not, it's a 1 there. So our a value is 1. Our b value, again, I'm going to take b out with its sign. So my b value is -4. And my c value, again, same thing with the sign, is -12. Oops, -12. Okay, so now I'm ready to go ahead and plug into the formula. So x equals, I write everything just the way it appears, the opposite of b. Now b we said was -4, so the opposite of -4, of course, is +4. I put the plus or minus sign. We'll talk about what we're going to do with those in a second. Okay, now b squared, I put that in parentheses, and I want to make sure I always put my b in parentheses when I'm getting ready to square it, okay, because we want to make sure that we also square the negative sign. -4, I'm substituting in parentheses, times 1 times -12, that's my c value, all over 2 times 1. Okay, so now we've plugged into the formula. The next step says that we should go ahead and simplify this completely, and we'll do this in a couple of steps. Take your time, there's no rush. Okay, you're better off writing out the steps one by one as we go. So 4 plus or minus, I'm going to start by simplifying the radicand. Remember, that's the number underneath the radical. So -4 squared means -4 times -4. That's a +16. You can see why it's important to put that -4 inside parentheses. Now, I have minus. When I multiply 4 times 1 times -12, I get a -48. That whole thing, I can also simplify the denominator at this point. That whole thing is over 2 times 1, or 2. Okay, so let's keep simplifying that radical. 4 plus or minus the square root. This becomes 16 minus -48. Okay, I can change those both to positive, so it's 16 plus 48, or 64. Okay, all over 2. Now, what I like to do is I'm ready to go ahead and simplify the radical. I like to tee this off. Mrs. Wood taught you about teeing off the other day. So what I'm going to do is x equals 4 plus, I'm going to simplify the radical as I tee it off. So 4 plus 8 over 2, and x equals 4 minus 8 over 2. Okay, so what I've done is I've teed it off and split up the plus and the minus. I've given one side of my t gets the plus, the other side gets the minus, and I can go ahead and finish simplifying this out now. I get x equals 12 divided by 2, or 6, and I get x equals negative 4 divided by 2, or negative 2. Okay, so now these are my solutions. Just like when you use the square root method, you typically got 2 solutions. These are my 2 solutions to this quadratic equation. Now, what I'm going to do is go ahead and take those back up and check them. Okay, so let's check to make sure that they work in the original equation. So, if I plug in the 6, I will have, give myself a little room here, I'll have 6 squared minus 4 times 6 minus 12 equals 0. And if we solve this correctly, this should be a true statement. So I get 36 minus 24 minus 12 equals 0. 36 minus 24 is 12. 12 minus 12 is equal to 0. So that works. So I know 6 is definitely a solution. Let me try the negative 2. If I do negative 2 squared minus 4 times negative 2 minus 12, and does that equal 0? Well, negative 2 squared is 4. This becomes plus 8, and then minus 12 equals 0. Well, 12 minus 12 again equals 0. I know I'm correct. Good job. All right, let's try another one. Now, notice what we'll do is we'll mix up some of the A, B, and C values. I want to give you some experience using different values. So, step 1, A equals 2, B equals negative 6, that's the coefficient of x, and C equals 3. So I plug into my formula, x equals the opposite of b, so b is negative 6, so therefore the opposite of b is positive 6. So 6 plus or minus the square root b squared, so again, put that in parentheses, negative 6 squared minus 4 times a, which is 2, times c, which is 3. Okay, and this whole thing will be over 2a, so 2 times 2. I'll start simplifying underneath the radical and also the denominator, so 6 plus or minus the square root. Negative 6 squared is positive 36, and this becomes positive 36 minus 24. And the whole thing is over 2. Okay? And so I can simplify my radicand. I have 6 plus or minus the square root of 12 over 2. And I'm ready to tee it off now. So if I tee this off, I get 6 plus the square root of 12 over 2, and 6 minus the square root of 12 over 2. Now, the square root of 12, sometimes I like to simplify the radical off to the side. I'm looking for the largest perfect square that's a factor of 12. That would be 4. So this would be square root of 4 times the square root of 3, or 2 rad 3. Okay, so I can go ahead and take out the square root of 12 and put in the 2 rad 3. So x equals 6 plus 2 rad 3 over 2. And x equals 6 minus 2 rad 3 over 2. Almost done here. Last thing I can do is I can simplify my answer here. Okay. Now, here's how we simplify it. We can simplify this to the 6 and this 2. We can never use the radicand when we're simplifying. Okay, so if we had the square root of 6, let's say, the radicand was a 6, we couldn't use that in our simplification, but we can simplify these 3 values, and we can only simplify if something goes into all 3 of those values. And you notice that 2 goes into all 3 of those. So 2 goes into 6 3 times. Okay, it goes into itself 1 time, and it would be over 1. But again, we learned if there's a fraction is over 1, you could just represent it by that value itself. So it would be x equals 3 plus 1 rad 3, or 3 plus rad 3. And the same thing here, we'd have x equals, it's going to be 3 minus rad 3. So those are my 2 solutions. Now, you might ask, how am I going to check those? Well, you can actually plug those into this equation. Okay, you could use your calculator to help if you need to, but you could definitely plug those values in. Okay. A couple more examples here I just wanted to run through. Notice that on this example here, a is equal to negative 1, b is equal to positive 4, and c is equal to positive 10. So as I plug into the formula, x equals the opposite of b, so negative 4, plus or minus the square root of b squared, 4 squared, minus 4 times negative 1 times 10. Extend my radical a little bit. Okay, all over 2a, so 2 times negative 1. And so let's start simplifying. Negative 4 plus or minus the square root of 16. 4 squared is 16. And then this will become a plus 40. Okay, whole thing over negative 2. So x equals negative 4 plus or minus the square root of 56 all over negative 2. Now, square root of 56 is the square root of 4 and the square root of 14, or 2 rad 14. So when I tee that off, okay, I can go ahead and say x equals negative 4 plus 2 rad 14 over negative 2, and x equals negative 4 minus 2 rad 14 over negative 2. Okay, now can we simplify in all three places? Yes, yes, yes. Negative 2 goes into all those values. Remember, you cannot touch the 14 because that's underneath the radical. So, okay, essentially if I say how many times does negative 2 go into negative 4, it goes in a positive 2 times. How many times does negative 2 go into positive 2? A negative 1 time. Square root of 14, and then how many times does negative 2 go into itself? Once. So we get x equals 2 minus rad 14, and x equals 2 plus rad 14. And those are my two solutions. Okay? Now, one more example that I wanted to go through, and this one's interesting, because what do we notice right off the bat? Something's missing. Okay, and that's the c term. We notice that the c term is missing. So when I evaluate, or when I identify a, b, and c, okay, my a value is 3, that's pretty clear. My b value is 15, that's great. Now my c value. Now remember we talked about the ghostly 1. When there was just an x squared to start the expression in standard form. Well, here that's not a ghostly 1. Here, really, we can rewrite this as 3x squared plus 15x plus 0. Okay, if the whole term is missing, then we hold its place with a 0. So in this case, our c value is going to equal 0. Okay, that's the case. Sometimes the b term will be missing. Okay, just like Mrs. Wood talked about the other day. When the b term is missing, actually we could use the square root method. But if you're going to use a quadratic formula, when the b term is missing, you plug in 0 for b. Okay, so when I use my quadratic formula, x equals the opposite of b, so negative 15 plus or minus the square root 15 squared minus 4 times 3 times, now c is 0. Okay, all over 2 times a, so all over 2 times 3. Now, let's simplify starting with the radicand and the denominator. So negative 15 plus or minus the square root. Okay, so we're going to have, underneath, we're going to have this 15 squared is 225. Now notice that 4 times 3 times 0, it becomes 12 times 0, or 0. So we really just end up with the square root of 25 all over 6. I'm ready to go ahead and tee this off. So I'll have x equals, forgot my t, x equals negative 15. Now the square root of 225 is 15. Okay, over 6, and x equals negative 15 minus 15 over 6. So x equals 0 over 6, which is 0, and x equals negative 30 over 6, which is negative 5. Plug those two values into double check. Okay, make sure that we've simplified this correctly, and we'll find that they both work. Okay, so now you guys are going to do some practice, and then your teacher will, you have an opportunity to meet with your specific teacher to answer any questions, and good luck, guys.